We've talked about the idea that the lines of an equation, or once you graph that equation's line, every single point of that line shows a possible solution for the equation, or actually one of the solutions for the equation. Um, at times you're going to be faced with two different set of questions, and they'll just pop up in random places. Sometimes it'll have something talking about verifying if that point's actually on the line of that equation. And so they'll give you an ordered pair, um, and then they'll give you an equation, and they won't give you a graph usually. And they ask you, hey, does this ordered pair, this point, is it on the line of this equation? And there's a trick that you can actually do to verify if that point is on the line of that equation without graphing it, and that's very helpful. And then there's another time where basically they'll just flat out ask you, hey, is this point a solution to the equation? And that's really doing the exact same thing. We're just going to take the x and y values and plug them into the equation and see if it makes a true statement. So we're actually going to play around with this a little bit and show you what happens, and then we'll actually graph it to prove it. So here's the first type of question. Verify if this point actually lies on the line given by the equation x plus 2y equals 7. So um, what we can do is literally just take the 1, which is an x value, and take the 3, that's a y value, and plug it into their proper places for this equation. And since the y is multiplying the 2, I'll just write the 3 in parentheses to show that multiplication. And now let's go through and see if it actually makes it into a true statement. Now see this right here? This means that the equation is true. So yes, this point does lie on the line of this equation, because when we plugged it in, it made it a true statement. Now, how can I prove that to you to make sure that you know uh, that it's true, that this point is literally on this equation's line? Well, we can go and graph it. So let's go ahead and just graph 1, 3 right now. Here's 1, and there's 3. And now let's basically go back through and convert this into the slope-intercept form. And you should know that you would just be minusing the x onto the other side of the equation. And then we would just divide by 2. So it's going to be negative 1/2 x plus 3.5. But we'll just write it as 7/2. So let's go to 3.5. There we go. That's our y-intercept. And now let's go down 1 and over 2. Does it look like this point is right there on the line? Well, that's because it is. And there you have it. We've graphed x plus 2y equals 7, and it hits the 1, 3 point. How can we do this without even having to graph it, without having to flip it into the slope-intercept? Just take this point, this ordered pair, plug it into your given equation, and see if it makes a true statement. If you got something like 6 equals 7, something that's not true, then you would say no, this point would not lie on the equation. But since it did make it true, yes, it is. Now, let's take a look at the other type of question. And instead of saying, hey, is this point on the line of the equation, they're going to change the wording up. And they're going to say, is this a solution to the equation? And it's the exact same thing, because remember, every single point that's on the line of the equation is a solution. So basically, it's the same type of question. They're just wording it differently. All we have to do is take these and plug it in. So the 4 is the y value, so let's put the 4 right here. Let's actually get a pen out, though. There we go. This negative 3 is multiplying the x, which is 2 in this case. That's what they're asking us about. This is the x value. And now we just follow our order of operations. Multiplication first, that's going to equal negative 6. This is the plus 2. And here's the 4 there. Negative 6 plus 2 is negative 4. And this is positive 4. So it's a resounding no this is not a solution. And let's just go ahead and graph it. It's y equals negative 3x plus 2. So my slope, which I'll refer to as m, is negative 3. And my y-intercept is also referred to as b, is positive 2. Let's go and graph positive 2 right here on the y-axis with our y-intercept. Let's make our slope into a fraction. So this tells us that we'll go down 3 from our y-intercept, and we'll go to the right once. So down 3 and to the right once. There's 2 points. We can go on down and do that again if we'd like. There's 3 points to be safe. Let's graph our line. And then just to double check, let's graph 2, 4. So let me get my pen out again. This time we'll put it in blue. Here's 2, and there's 4. So since this point is not on the line, I know that it can't make it true. But we knew that. I just wanted to show you that once you plug in these points that are not on the line, it gives you some sort of bizarre statement that is not true, two sides that do not equal each other, and it just saves you the trouble of having to graph.